All right then. Okay. So thanks very much, Tom, for hosting this session. It's been very interesting. And I'm going to talk about some reflections I've got on teaching workflow in the context of a research study. And so I started using R 2007 because I needed to do mixed effects models. And I started teaching R classes, workshops and classes in 2013, and moved to Lancaster, partly so that I could get to do that, as it were, officially in 2014. I wasn't aware at the time of the work that Glasgow was doing. So when I started teaching R, I was sort of, what I had to do was just put together my own materials, much like Glasgow had done, writing book chapters, and so that I could sort of ground the teaching in psychology materials. And I thought it's important to do that, and I still do, because I think when students come into contact with coding and with statistics, it's helpful at least to scaffold that learning experience in terms of work that they care about directly. So, developmental, psychological, experimental data examples, that sort of thing. What you'll see in the presentation that I'm going to give now is many elements which present parallels with the things that Emily talked about, and you'll see a strong sympathy, I think, of approach in what I'm going to talk about with the things that Emily talked about, particularly with respect to reproducibility. And the reason I wanted to teach, and this was in master's classes in 2014, was I thought it was important that there were sort of what I thought were ethical imperatives to teach R and to switch away from SPSS, because of the greater capabilities I'd learned to acquire in learning to use R, because of the fact that R is free, and because, in the context of what we were calling the replication crisis, because of the fact that you could reproduce your results. So I had submitted a research report in 2013, which got published in Memory and Cognition, where I'd submitted data and code with the manuscript. And the reviewers of the manuscript had checked the code, run it, and basically said, yeah, this works fine. And I just thought that was amazing. So that's what I wanted to teach, and that's what I started doing in 2014. So what I'm going to talk about today are things that I started thinking a bit more about recently. And as Tom said, I was asked to contribute to undergraduate teaching. And I think what I've been thinking about lately has really focused around workflow, partly because of this impetus, but also because of my involvement in kind of complex multi-site, multi-year research projects where you have to think about workflow a lot. So where I'll begin with is by saying this. Most people who analyze behavioral data for a living recognize that their work proceeds through a series of stages or workflow. And I think we should ground research methods learning in a workflow as a framing device or a narrative device, in the same way that we might ground methods teaching intellectually or conceptually in terms of the linear model and generalizations of the linear model. I think teaching R in relation to workflow aligns very well with teaching research methods in terms of projects. Thinking about workflow makes sense because our work progresses through stages. And I think thinking about workflow makes sense when we talk about teaching, because R functions enable each stage of the flow. So, when I started out using R like 2007, 2008, I just used the functions that allowed me to do mixed effects models, and everything else was SPSS or Excel. But pretty quickly, I figured out that I didn't have to spend days tidying data in Excel by hand. I could actually get functions to do this in milliseconds. I think in projects, we think about workflow because early stage work needs to be got ready for late stages. I mean, that's obvious, but it's typically not apparent in the way traditionally we teach statistics. But as Emily said, it's so important to allow for productivity and effectiveness. So I suppose for psychologists, we've got two kinds of researchers. We've got people you might call craft workers, who basically need to do everything from start to finish. And they need to do all the stages efficiently because they're person who has to do everything. And you've got people who work in teams, so team workers who basically have to hand products from one stage off to the people who have to do the next stage. So, for example, I work at an NIH as part of an NIH-funded project. And we have, one set of people doing the data importing and tidying, and another set of people doing the analysis and the communication. And we need to make sure there's good flow through that process. So I'm thinking when I talk about these things, partly about, the kind of the real life employed context in which our students exercise their skills. I would argue, though, I step back from a little bit from those sort of practical concerns and argue that, we recognize that there are, things that are workflows, objects or framing or narrative device, because we can see that they can vary. And I suppose we started thinking about this overtly, famously, given the identification of researcher degrees of freedom by Simmons and colleagues. And because they were talking about particular decisions you'd make at critical points in your analysis workflow. But I think it's important that there's been work, a lot of work really, where people examined all the stages in the whole workflow. And, where you've got an indication of, for example, by CARP, 6,912 analysis pipelines in fMRI, or the count by Clough and colleagues in 2020 of over 1 million possible different analysis strategies in observational data analysis. So what we're talking about here are the number of different ways in which you can get from data to analysis to results. And we see then, many different gardens, so many different gardens of forking paths. And it's in this recognition of the variability, of the flexibility, that we recognize that there is a thing that we can think of in terms of workflow. So we recognize workflow because the choices change results as well. So we have demonstrations that the way in which you construct your data set, the processing, the coding, the way in which you slice things, exclude things, or include things, has a direct impact on your analysis results, whether you're thinking in terms of p-values or estimates. And we see that there is what you might call a models multiverse, where you have demonstrations that you can give different teams the same data set, and they will come to a variety of different conclusions because they're using different methods. And here, everybody's using reasonable methods. Reasonable people will differ, however, and you're going to get different results in terms of the magnitude and sometimes the sign or the estimates alongside differences in p-values. So this has come to, this is, I guess, stimulated the realization that we need to develop something like what you might call a theory of mind for data analysis reporting. So, apologies for people who actually work on theory of mind. So this, in my ignorance, is what I'm going to call a theory of mind for data analysis. So it seems to me that the combination of the analysis flexibility plus incomplete reporting is one of the serious problems that there is in scientific practice, certainly in psychology, but also in other fields. And I think it directly makes it difficult to evaluate or to reproduce results that we read about. And certainly when Lottie Metayard and I reviewed mixed effects modeling practice in psychology, we found that people are using tons of different ways in which they were processing and fitting models and reporting models. That plus incomplete reporting in the papers meant that it was really difficult sometimes to work out exactly what was going on in the analysis or how people had got to the results that they were reporting. I think in sort of often in traditional teaching, a lack of awareness of alternative workflows is why methods and results reporting can be so incomplete and biased. What you get is often this kind of illusory certainty around what you do, because what you do is what we do. It's what we do in the lab. It's what this PI does. It's what we do in this field, or it's what we do by default in this journal, or it's what this teacher tells us to do. And I think one of the things we need to cultivate is the sense that actually this is a thing we do. This is a workflow we adopt as a series of choices, but there are other choices. And I think we need to do this because if we know there are choices, then we know we need to explain our choices. And this is why I guess I think about theory of mind and the development of theory of mind, because, you know, I often ask students to explain their reasoning, you know, tell me about your decision, tell me how you got there. But sometimes it's unclear why I'm asking that. And I guess the reason why I'm asking it is because you could have made other decisions. So I think this is why teaching the whole workflow is not displacing statistics with practical data science. We're not sort of taking chunks out of, you know, time we could be using on statistics and just putting into it programming. Because it has, these considerations have a direct impact on the results that we end up reporting in our papers. Of course, we can collapse the space of alternative workflows through registered reports, through pre-registration. I guess that's fine and that's good, I think. And I do pre-registration as well as part of my practice, but I'm interested also in the rich benefits that you can get by developing the scientific virtues that Andrew Gelman and Hennig have proposed in 2020, where you think about transparency, consensus, impartiality, correspondence to observable reality. And what I'm highlighting, because it's what I'm most interested in my practice right now, awareness of multiple perspectives, awareness of context dependence, investigation of stability. If you think about the variation in results that's been demonstrated with variation in workflow, in data processing choices, in analytic choices, then it seems to me that one of the things we should seek to establish scientifically is the extent to which our results do or do not depend on the particular choices we make. So in this context, thinking about R and thinking about using R makes sense because increasing the span of your competence increases the span of your reproducibility. Focusing attention on workflow in teaching R in methods classes, I think, is a device for a mechanism or a framework in which we seek to improve reproducibility. Because what we're then going to be able to do is not just talk about statistics, you know, as Emily said, but also ensuring that as much of the workflow as possible happens in a documented fashion. So, you know, what you learn to emphasize, I think, is basically doing everything in script. So there's no off the books by hand messing about with Excel. You know, it's in script only data processing, analysis and results presentation, self-explanatory, self-explained coded work. And what you also get, and this is something that I talked a little bit about in the chat, you have these benefits coming with R functions and R libraries that are available to you as you learn to develop skills in R, but you also get coming with it, I think, what you might call cultural side benefits. So, you know, I learned, you know, it was a revelation to me, but I learned to think about file system discipline, helpful naming practice, and version control because I was working in R and thinking about, you know, teaching R. And I'd like to pay tribute here to Jenny Brown's work, which is really, really helpful. And, you know, her teaching materials were Stat 545, I think it's called, hosted on University of British Columbia. Really helpful sort of materials where you can sort of think about how you can get all the bits and pieces of your work to flow together in an efficient, effective manner. So that's the kind of the framework for, you know, the motivations for thinking about workflow and situating methods teaching in terms of research projects. So what actually happened when, as Tom said, I came to work or came to contribute to a 4-week first year undergraduate mini course. So this next part of the presentation will be talking about, you know, basically what did we do. So the title, you could say, is I didn't sign up to do programming, or what we did and what we did not do in a project-focused mini course. So where I started with was with sort of what you might call folk theory ideas about how you have to teach statistics or research methods in R. And these, I guess, are ideas I've built up since, you know, starting to teach it formally in 2014. So I think you need to situate method learning in research that matters to us, to the students. So why should we engage? Well, because these projects that we do matter to the world, matter to your interest in psychology, and we need to do those projects better. I also think we recognize, you know, that diversity matters from the start. So everybody works differently. Everybody's coming from a different place. You can have clusters of students, subgroups in your cohort working at different speeds. Even though our students are often referred to as digital natives, I learned to unbelieve that slogan. It's often you see it in university documentation, and to basically start to assume that students often come to classes with no prior knowledge about what variables are, or what files are, or how to find them in folders, or anything like that. And I also thought it would be important, and this is something I've thought about more, that we collect data with not on student participants, and we try to treat them, if we can, as co-authors, as collaborators. And because of my involvement in research on reading and reading comprehension, I was also aware of the fact, as I started this work, that it's easier to understand ideas presented in narrative, or what you might call narrative text, or explanatory context. So this involves basically saying, these things happen because of this, we're doing this because of that. So always the because, always the causality, always providing causal links in justifying or motivating the reason for doing things and for the steps that we're teaching. So the pitch, what you could call the sales pitch for the students, so why we're going to do this, was that this is teaching I was doing in February, March of this year. So living in lockdown is pretty miserable, and it's even worse if we're feeling helpless about it. But perhaps we can do something to make a difference. And this sort of piggybacks on work that I was doing in collaboration with Public Health England, funded by the ESRC as part of an impact acceleration grant, where I was looking into or thinking about how we evaluate guidance, written guidance about COVID, for what makes it easy or difficult to understand. So what I was asking the students to do is to work with me in a project where we could figure out what made COVID guidance easy to understand. And this is in the context of an understanding which was pretty clear through 2020, that behavior and what people decide to do was critical to handling the pandemic. And also in the context of survey results suggesting that what was critical was self-reported understanding and variation in that self-reported understanding. And back in June 2020, you may remember, there was survey research suggesting that young males were not really paying attention, or not really showing good understanding of compliance of behavioral distancing guidelines. My question was, this is self-reported understanding, but does that actually marry up with actual understanding? So what we did was we set up a project where we were seeking to evaluate two questions, answers to two questions. How do people vary in response to COVID guidance, and can we judge our own understanding? And one thing I was keen to do was to talk about the way in which, and discuss and evaluate with students, the way in which we go from research questions to questions of operationalization. So how do we prepare materials? How do we test these constructs? How do we do it in a way that makes sense? And then how do we get to our tests of the hypotheses? So we tested understanding in terms of multiple choice questions. We tested self-ratings of understanding using 9-point ratings. And we also asked questions about age, gender, ethnicity, and health knowledge using Qualtrics surveys. As part of teaching, or in order to teach R in the context of a workflow, I talked about where we are in each stage of the workflow explicitly, and where we're going to next. I stopped introducing new statistical tests. So I had the benefit of teaching these classes at the back end of the first year. Tom and John, and then Marguerite having taught statistical tests. There were no new tests being introduced towards the end of the year. What we were doing is working with the tests in a workflow that would get us from research questions to answers given the data. We were using functions introduced previously, and we were working through tasks, the kinds of tasks you'd need to do in a professional context to provide evidence in order to address the questions that you've got. As part of this, also, I introduced ideas around exploratory data analysis, so using visualization to examine your samples, and in order to give a basis for critical evaluation, reflection on our results. So one of the things we're interested in terms of COVID guidelines communication is differences socioeconomic and other differences in responses to the guidance. And, what I was wanting to provide a space for students to realize is that we're collecting data. So this is, we can visualize the data that we collect from ourselves. And this is, responses you can see in the plot showing the differences in accuracy of response to COVID guidance in different ethnicity groups and different, what you might call so-called gender classification groups or self-classification groups. And it was very obvious as soon as you start doing this work that you may well run a multiple regression or linear model where you might have ethnicity or gender as factors, as predictive variables in your model. But you have massive imbalances, certainly for a psychology cohort, both in terms of gender and in terms of ethnicity, which is going to have an impact on what you think about or how you think about your results. We also use plotting very much to think about variation between samples, both variation between samples and uncertainty about estimates. So we have the benefit here of doing a study that with the students, where we're collecting data with the students, where it's one study in a series of studies. As soon as you present studies in the context of a series of studies with similar methods addressing similar questions, as soon as you allow students to examine, compare data from different studies, then you reveal, I think, or you make transparent and clear the way in which the size and the directions of estimates of effects or associations may vary between samples. And you get variation also in the relative uncertainty of your estimates. So you start to introduce these core concepts from very early on in the context of active research programs about questions that perhaps matter. At a, what you might call micro level in practice, we were interested also in ensuring that the steps between the transition between practical steps was made clear. And we exploited then the kind of tidyverse use of pipes. So we're basically saying to students, you're going to read in your data, then you might have to do some recoding, step 2, and then you might have to do the plotting, step 3. And as part of the plotting, you're going to do a series of steps where you're going to edit the appearance of the plot in order to communicate precisely the message you want to communicate and nothing else. So I'm running out of time now. So what I'd like to flag at the end is my sense or my reflection of what we did and what we did not do. So, as it were, my regrets and what I thought was good about what we did. So we managed to work in a slice through the typical workflow. So nothing about materials preparation, but we did do recoding factors, visualization, linear model, and critical evaluation of results given the visualization. We didn't teach or learn good file system discipline, good naming practice, version control, or R marker. And I'd like to see us expand out the classes so we do this more fully. We did encourage students to comment on the study. And of course, we received insightful comments. But we didn't do as much as I'd like to, rather, I didn't do as much as I'd like to have done to facilitate autonomy around project implementation or analysis solutions. So I really like the practice that Emily talked about, where students are doing their own sort of bits of projects, but you're able to bolt together, real data sets of really useful sizes, of 1,000 participants or whatever. So what's next for this project? We'll share materials, data, and code on Open Science in an Open Science Framework repository, and we'll share the results and the reflections in a SciArchive preprint. Students will be credited as group authors and invited to co-write reflections and credited by name if they contribute text, because, as in the slogan from American Healthcare, nothing about us without us. I think it's important that we sort of move away from this kind of doing data collection on student participants and then just basically sort of benefiting from it without giving them a chance to reflect on it. And students have reflected on what they've thought and talked about how, what do the imbalances mean? What are exactly the right ways to get these kinds of data? Really helpful stuff, I think, and really important that they're recognized in this process. So that's it. Thank you very much for your attention. And any questions will be welcomed. And I'll put my Twitter handle in chat, or email's fine too. Okay, so I'll stop sharing now, and thank you very much.
Thanks, Rob. That was great. I think we've got one question just popped up about. I think it relates to your talk, teaching good file system discipline. and these sort of basic skills. I know we've had issue with that sort of thing in our first year program. We talked about it a lot, about the fact that students, as you said in your talk, they're not very tech savvy, or a lot of them aren't, and a lot of them come in with very poor knowledge of operating systems. Is there anything that you sort of learned over the year about how we might better prepare students for what we're eventually going to need them to do in this course with respect to basic computing operations and organization and that sort of thing? You said you'd sort of put that into a lot of your teaching materials.
I think what I've done is it's been pretty one-dimensional, and I'd like to figure out a richer way of doing it. So it's been something like, here are examples. Here's a layout that I'd like you to adopt, and here are things that I'd like you to do. But I think it's, what I should have been is braver, and sort of said, let's open your file folder or Windows Explorer or Finder or something. Let's see what's there and what you make of it, and be more interactive. Because I think what happened was that I guess every year I'm surprised by how little students know about. I shouldn't be, because it happens every year, but I'm surprised by how little students know about what variables are, what a file is, and what folders are, and things like that. But I think we sort of, I guess next year I'm going to be prepared for it. And it's just got to be the case that I'm just going to have to walk students through like the digital world, the kind of virtual world. And I think that kind of collides with that sort of response that students have, where they said, I didn't do a psychology degree to like learn programming, but you said, and that's I guess my response to that will be, we're doing this research project where we want to answer this question that we all care about. How do we make sure this stuff works properly, as in COVID guidance? There's no way around these things that we have to figure out, to learning to do. So that's what we're going to have to just take on the chin. So I think in that context, it sort of gives you perhaps space in order to do these things, and then we'll have to sort of teach, a file is this kind of a thing, and a folder is this kind of thing, and these are the places you can find it. But in a sense, what I would do would be to start with kind of a learner art tutorial sort of sandbox thing, and then kind of pull away the curtain and say, actually, this is all in a place. It's not really in a place, sort of in a virtual place, but something like that, and just kind of basically unwrap it. Much like, I guess, when I was at school and did chemistry, and like when I was 11 or 12, they were talking about like atoms like planets with moons and stuff, electrons going around the planets and stuff like that. And then they just sort of ripped it all apart 15, 16, and said, hey, no, it's about energy levels and probability and stuff. And you were like, what? And I think we have to do that. We have to bring them in and sort of say, actually, it's about these things that you can learn to do.
Because part of the problem is it's sort of the boring stuff a lot of the time that you're trying to, with this sort of level of tuition, you're trying to put in these good practices, but it's kind of pretty boring for the students to sort of hear about, well, you need to organize your file system and name your file like this. And similarly with, when you do any coding, everybody says, now you must comment your code, and make sure you write comments, but you do that for one tutorial or one lesson or something, and then they've forgotten it, and then they don't do it again. I mean, how?
Yeah. So I think that's a great point. So I would say this is my lesson then. This is what I've learned. Interaction is key, because it's hell when I get a file from a colleague, professional colleague, or a student, and it's basically final.sav, and the variables are, variable 1, variable 2, variable 3, and coding levels are 1, 2, 3, and 4. And I'm like, okay, so I'd like to be able to help, but first we're gonna have to sit down through it. And I think likewise with looking at commented code or badly commented code, it's horrible. And I think we basically have to expose students to that experience of, tell me what this means, or tell each other what this means. And actually, these angry feelings that you're having, or the sadness or the despair that you're having because you're looking at the stuff and you can't make out what your colleague is doing. This is stuff you don't need. You can get rid of that straight away just by, doing these things, by good file naming practice and stuff like that. I mean, I work with Americans, and month, day, year, I just say, stop doing this.
How does it feed? How does that sort of stuff feed into assessment? I mean, is it possible? Is that necessary? I mean, I always feel like students don't really do anything unless they know it's going to be part of an assessment. I mean, is it possible for that stuff to feed through to an assessment? I know that. I mean, I don't know. I apologise to Emily if I missed this in her talk, but is it not true that Glasgow had them sort of uploading our Markdown files as part of their, so like fully processed sort of our Markdown files, and that they were assessed on the basis of those, and presumably the extent to which they're commented and well documented and stuff is part of it. I don't know. I'm just sort of recalling what I've seen in the past. I'm sure somebody had done that.
I've seen Lisa De Bruyne in Auburn. They might like to speak to that directly, using our Markdown submissions. I think we should move to that too at Lancaster. I think it's really important. I just haven't been brave enough here too.
But that's something we could come back to in the discussion as well.
So certainly in the master's classes I've been teaching, I asked students to add R code appendices to reports. So they write research reports based on secondary data analyses, and I asked them to put code in the appendix and comment on it. I give them feedback on their commenting style. I don't assign marks to it, partly because I wasn't sure how to grade it, so which is why I'd be grateful to hear Emily or Lisa's comments about this. Because I think it's about style, teaching style, right? Yeah,
we could come. I think Emily's put a thing in the chat about it, but we could come back to that in the discussion and go over that more. Does anyone have any other questions on Rob's presentation? Feel free to unmute yourself and ask a question. There's some other really good points. There's a discussion in the chat about, the style of inferential stats teaching, and whether you go for a sort of a catalogue of tests as we're currently teaching in undergraduate, or you sort of teach the linear model as the starting point and stuff like that. That would be interesting to come back to as well, in discussion to hear what others are doing there. So, okay, thanks very much, Rob. Then we'll move on to Mark's talk as our final talk of the day. Goodness me, we're on time. This is remarkable. I didn't think we'd be here. Okay, over to you, Mark, to share your screen.
Okay,